For a start, let's try to establish a relation between the masses of the reactions and the masses of the products in a chemical reaction. We will try out several combinations of reactants and make quantitative measurements. Here are lead nitrate and potassium iodide. Lead and some of its compounds are toxic. Therefore, handle and dispose of these very carefully. We also have acetic acid and sodium carbonate. We need a digital balance that reads 2 decimal places, Erlenmeyer flasks, and some balloons. Watch closely as Jenny De Jesus performs a demonstration. Before weighing the reactants, place a balloon and flask on the balance pan. Adjust the tare to 0 to cancel out their mass. Pour about 100 milliliters of a 0.2 molar solution of potassium iodide into the flask. Transfer about 1.6 grams of lead nitrate into the balloon. You do not have to use these exact quantities, but you do have to follow the procedure described here. To ensure an airtight system, fit the balloon snugly over the flask. To determine the exact total mass of the reactants, place the entire setup on the balance pan. Record the total mass. Watch carefully as Jenny drops the lead nitrate into the potassium iodide solution. This is a colorful reaction. A yellow precipitate forms. This is one indication of a chemical change. Has the total mass changed? No. The total mass remains the same, 102.95 grams. We observe that the total mass remains unchanged or is conserved in this reaction. A single observation does not make a scientific law. To establish a law, more observations should be made. Countless experiments have shown this general pattern. The total mass of the reactants of a chemical reaction is equal to the total mass of the products. This is the law of conservation of mass. Mass is conserved in a chemical chain.